Hi guys, this is Mrs. Denton. Today we're going to do lesson 4.1, Relations and Functions. Grab you some notebook paper, get ready to write down some vocab and some warm-up problems, and then we'll get started. Okay, on the warm-up we have a couple equations that say solve the equation, check your solution. So if you will pause the video and solve both of these for x and come back and see how you did. Okay, in example 1, we have negative 2 3/10 plus x equals 9 1/10. Now, a couple ways we can look at this. We're always going to start on the side of the equal sign where our variable is. In this situation, we'll be on the left side. Now, our goal is to eliminate this negative 2 3/10. So we can pair it up with its opposite, or we can move it across the sign and change the sign, if you'll remember doing that. Or if you would prefer to add the 2.3 and get rid of it that way, you're doing essentially the same thing. So if we move it across the equal sign and change the sign, we're still adding 2.3. So put that into your calculator, 9 1/10 plus 2 3/10, and you're going to get 11 4/10. Okay, same process with number 2. We have 6 1/2 plus x equals negative 4 3/4. We're going to start on the left side again because that's the side of the equal sign our variable is located on. Our 6 1/2 is a positive, so we're going to move it across the equal sign and we're going to change the sign. Or you can think about doing the opposite on that side. Either way is correct. Bring down our x, put into our calculator negative 4 3/4, subtract 6 1/2, and it's going to give you a negative 11 1/4. Or it could possibly have the decimal version of that, negative 11.25. Okay, let's look at some vocab here. So in this chapter, we have several vocab that we're going to see throughout the rest of the chapter and use with each lesson in the chapter. So it's very important that you make some notes and look over these or use these as we go along to each lesson. Okay, the first set of notes says ordered pairs can be used to show inputs and outputs. Now, the word input is just another term or vocabulary word for the x value. The word output is another term or vocabulary word for the y value. So just like we have an ordered pair where we have our x, comma, y within parentheses, we can think about that as the same thing as our input and our output. And if you are thinking you might get these mixed up, just for a second, think about your x comes before your y in the alphabet. So they're in alphabetical order. Your I comes before the O in the alphabet, so input-output would be in alphabetical order as well. Our next vocab says a relation pairs inputs with outputs. So it places the x value with the y value. A relation can be represented by ordered pairs, which we've been working with for several weeks, or a mapping diagram. Now, the mapping diagram may be something new. It's very simple as well. It's as simple as writing it as an ordered pair. It's just a different way of representing it or organizing the same information. So down below, we have an example of some ordered pairs, and I just marked through that, so let me erase that real quick. So on the left side, we have our ordered pairs. Remember, they're written as x, comma, y. And over on the right side, we have an example of the mapping diagram for these same ordered pairs. So look at the organization for the mapping diagram. Our first column is basically our x's, and our second column, the output, is our y. Now, the way that we would read this or pair these up is the arrows that are connecting them in the middle are telling you how they're matched up as an ordered pair. So the first value in the input list is 0. 0 has an arrow pointing to 1 in the output. So that ordered pair would look like 0, 1. The next one is 1 in our input or x value list. It has an arrow connecting it to 2 as the output. So that ordered pair would look like 1, 2. And the last one is a 2 in the input list, and it's paired up with a 4 in the output list. So that would just look like 2, 4 as an ordered pair. So a mapping diagram can do the same thing as listing ordered pairs. Okay, example 1 says, list the ordered pairs shown in the mapping diagram. So we are basically going to take the information in the mapping diagram, follow the arrow from, remember, our input is the x, our output is the y, and we're going to follow that arrow to make a connection and write it as an ordered pair. So this first one is pairing up the x is 1 to a y that is 3. So the ordered pair for that first set of values is 1, 3. Then we're going to separate this with another comma, and we're going to pair up our next number in the list, which is 2 and 6. So the next ordered pair would have a value, x value of 2, a y value of 6, comma. Next we have 3 and 9 as an ordered pair, so 3, 9. And last we have 4 and 12. So 4, 12. And that is how you list the ordered pairs shown in the mapping diagram. Okay, you try B, pause the video if you need to, and then come back and see how you do. Okay, on the first ordered pair we have 0 connected to 0. So that would be 0, 0 as my first ordered pair. The next one you might notice is something different. 2 has 2 arrows coming from it. The first arrow connects it to 1, so that would be an ordered pair. And the second arrow connects it to -2, making our next ordered pair. So 2, -2. And then we have one more, 4 being connected to -3 as an ordered pair. And that is how you list ordered pairs shown in mapping diagrams. Okay, some more vocabulary here. A relation that pairs each input with exactly one output is a function. Now, if you'll recall, the input is our x, the output is our y. So in order for a relation to be a function, each input has exactly one output. So each x only needs to be paired up with one y. That's what makes a relation a function. So that's what we're going to be looking for to determine whether a relation is a function or not. Okay, example 2, determine whether each relation is a function. So look at the previous vocab. If it's a function, each x has exactly one y. So we're looking to see if the x is repeated, basically. In example A, Look at our list of our input and our output. So we have, remember, input is our x, output is our y. We have an arrow going from -9 to 0. We have an arrow going from -2 to 5, one going from 5 to 10, and one going from 12 to 10. Now remember, if it is a function, and we can go back and look at our previous notes, each input, so each x, has exactly one output. Are any of our x's being repeated? Look at your x values. You have a -9, a -2, a 5, and a 12. Now, it looks deceiving because the 5 and the 12 are both being connected to the 10, but the 10 is our output, or y. So that's okay. So look at your list of x's. Each input has exactly one output. So we can say this is a function. So the relation in example A is a function. Determine whether each relation is a function. Yes, it is a function. And if we're asked to explain, we can simply say each input or each x value has exactly one output. Okay, now we're going to go through example B and look for the same thing. So we're looking to see if each of our input has exactly one output. So we have an arrow from -2 to 4. Okay, so far. An arrow from -1 to 3. Okay. Now look at 0. 0 is being paired with 5, but it's also being paired with 6. So does this input have exactly one output? No. X is being repeated with the output 5 and the output 6. Now our 1 pairs up with 6, which is still okay, and our 2 pairs up with 7, which is okay. But this 1x, 0, cannot be paired up with 2 outputs. So we're going to say no. This relation is not a function. And if we're asked to explain, then all we have to say is the x value 0 has 2 outputs, 5 and 6. Okay, let's look at example 3 now. Example 3 says, consider the mapping diagram at the left. Determine whether the relation is a function, and B, describe the pattern of inputs and outputs in the mapping diagram. Okay, so let's look at what we've got going on over here. We have our input, we have our output, our x and our y. Are any of our x values repeated? Are any of the inputs paired up with more than one output? No, each input has exactly one output. So for part A, where it says determine whether the relation is a function, yes, the relation is a function. And again, if we're asked to explain, we would just say each input or each x value has exactly one output or y value. Part B says describe the pattern of inputs and outputs in the mapping diagram. Okay, so we're going to look at the relationship. Relationship is just another word for pattern. So look at the relationship between the input and the output values. Also, I want you to notice what's going on between each input and each output. So if I'm looking at the relationship, first of all, between each input, I'm going from 1 to 2 to 3 to 4. So you probably already noticed that's increasing by 1 each time. Now our output is going from 15 to 30, from 30 to 45, from 45 to 60, and you can see a pattern there as well. Each output is increasing by 15. So when it says describe the pattern of inputs and outputs in the mapping diagram, we can put this into one statement. So I could say as each input, which is our x value, as each, if I can spell correctly, sorry about that, as each input increases by 1, comma, the output increases by 15. So that's one way of describing the pattern of inputs and outputs in the mapping diagram.